so we're going to go and look at the graph. This was problem number 17. And on problem number 17, I've filled out everything as far as the first derivative is concerned and filled out everything as far as the second derivative is concerned. But now I want to see more specifically, what is this graph going to look like? Well, I first approach this and look into, all right, what is my domain here? Well, if I look at x times x minus 4, where could that function either be 0 or undefined?
Has 0 and 4.
Well, that function is defined everywhere, isn't it?
Okay.
Yeah, so this function is defined everywhere. So my domain here is going to be all real numbers. Now, if this had been like the square root, then it wouldn't be defined at, well, it would be defined at 4, but it wouldn't be defined for any value that was less than 4. So we're good as far as the domain is concerned. Now let's go into looking at what the critical values are. We'll do the critical values. We take this function right here, and now I evaluated it down to here because it's going to make taking the second derivative easier. But if I want to look at my critical numbers, this step right here is a good place to look at my critical numbers. And I see from my critical numbers here that this would be at x equals 1 and x equals 4. So those are my two critical values here, because that's where the derivative is equal to 0. So my critical values are 1 and 4. Now, remember, those critical values are the points we go to look at to see where would we change from increasing to decreasing or decreasing to increasing. So I'm going to go ahead and plot this on the number line here. So I've got 1 and I've got 4. And I'm interested to see where we change, okay? So let's take 0, for example. If I plug in 0 here, I get a negative number, but then the negative number squared is positive. And then right here, I get a negative, so it's a negative times a positive, which is negative, so I am decreasing in this interval. Does that make sense? All right, so now let's go to 2. All right, 2 minus 4, this is negative here. And, but when we square it, it's positive. And then here we get a positive number, so it's positive times positive, so I'm increasing here. And then when I plug in 5, it's positive here, and when you square it, it's still positive, and then we positive here, so it's also increasing at 4. So I'm decreasing, and then I'm increasing. All right, so my intervals of increasing are 1 to infinity, and my intervals of decreasing are negative infinity to 1. All right. Now, at this next step, we get down to we want to look at what are my points of inflection. So I did the second derivative right here. And when I did the second derivative, I got x equals 2 and x equals 4 as my potential points of inflection. Again, they're not points of inflection until we switch. But as you see here, when I plugged in 0, I got something that was concave up because I had a positive second derivative. When I plugged in 3, I got something concave down because I got a negative second derivative. And when I plugged in a number greater than 4, I also got a positive second derivative. So I'm going to have my points of inflection at x equals 2 and x equals 4, but let's see what those critical numbers are. Well, if I plug in 2 to the original equation, f of 2 is 2 times 2 minus 4 cubed, which would be 2 times Negative 2 cubed is negative 8, so 2 times negative 8 is negative 16. So I've got the point 2, negative 16. That's going to be a point on my graph, and it's going to be a point where I change concavity. And then plugging in 4, well, 4 would give me 0 here, so the point at 4 is 4, 0. So these are my two points of inflection. Intervals of concavity, you're still concave up, negative infinity to 2 union with 4 to infinity, and concave down from 2 to 4. All right, now, there are a couple of other points in this graph that are going to be important to me. And those points are, I want to know any intercepts that I might have. If it's realistic, sometimes the intercepts are harder to solve for than they're worth for just sketching a graph, as far as that's concerned. But I also want to know what this point is right here for my critical numbers. So I already know what f of 4 is, but what would f of 1 be? Well, f of 1 is 1 times 1 minus 3, which would be negative 27, right? After I cube it. So it's just negative 27. So that's going to be another point on my graph. That's going to be my extreme value. 1 is in an interval that is concave up, so we know that that's going to be a minimum value. Intercepts, what do we get when we plug in 0? What is f of 0? Okay, so we cross at the origin. So let's start looking at what this graph is going to look like. And to set up what this graph is going to look like, and I'm going to erase this information right here because it's in the way, but we're good with it. I'm going to set up a chart with my important numbers. Now, my intercepts aren't really that important right here. My important numbers are really happening at 1, 4, and then 2 and 4. So I'm going to put 1, 2, and 4 on a chart. This chart is not necessary, but I've found, I used to not teach the chart, but I found that students tend to like it better with a chart. So I've got negative infinity to 1, I've got 1 to 2, I've got 2 to 4, and then I've got 4 to infinity. And this is going to help me shape my graph. So here's f prime of x, and here is f double prime of x. All right, so what do I know as far as f prime of x is concerned from negative infinity to 1? What do I see is happening? From negative infinity to 1, what's my graph doing? It's decreasing, good. So I've got something that's going to be decreasing. All right, now, after I've established that it's decreasing, what is the second derivative saying as far as its concavity? Well, I've got from negative infinity to 2, right? And what's happening from negative infinity to 2? I'm concave up. All right. Now I go from 1 to 2. Well, from 1 to 4, I start increasing, right? So from 1 to 4, I'm going to be increasing. And then this right here, 1 to 2, still falls in this range where I'm concave up. So I'm still concave up. All right, 2 to 4, I'm still increasing. In fact, I'm increasing the rest of the problem, so I'm going to go ahead and just include that here. But from 2 to 4, what do I know as far as my concavity is concerned? I'm not decreasing, but concave down. And then from 4 to infinity, what's happening? I'm concave up. All right, so let's think about what these graphs will look like. If I'm decreasing and I'm concave up, then that's going to take on some form of shape like this. If I'm increasing and concave up, then that's going to take on some form of shape like this. If I'm increasing and I'm concave down, that's going to take on a shape like this. And then if I am increasing and concave up, that goes back to this shape here. So my graph is going to change shapes at 1, 2, and 4. So let's go ahead and look at a graph, and let's look at plotting those points. And as we see here, it's 7 days until Caden's birthday, but I'm going to erase that for right now. So I'm going to sketch a graph out here. I go down to -16. So this graph, more is happening in the lower 2 quadrants than the upper 2 quadrants. So I'm going to sketch my graph like this, all right? So I've got -1, -2, -3, -4. That doesn't really matter because not much is happening to the left of the y-axis. We got a lot happening to the right of the y-axis, so 1, 2, 3, 4, and I'll go out a little further. 5, okay. Now, let's start plotting the points. These are gonna be numbered by 2, so 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16, 18, so -18, 8, -4, +5, all right. So I'm going to plot my points that are of relevance here, and again, my points that are of relevance, I've got the y-intercepts at the origin, so 0, 0. All right, then I have the point, what was f of 1? -20, oh, I gotta go further down. -27, so 18, 20, 22, 24, 26, 28. Okay, so I've got the point over 1 and down 27. All right, so that's the second point. Then I go to -16, so over 2 down 16 puts me about right here. And then my next point of interest is 4, 0. All right, so to sketch this graph, I'm decreasing and concave up to here. Now, this is kind of hard to draw because I'm only moving 1 unit to the left and 27 units up. So it's going to look almost vertical. So it's got to do something along those lines. So that's what decreasing and concave up looks like. Now from -1 to 2, I start increasing, but I've turned into concave up. Well, it's been concave up though, hasn't it? So I switch to here, And now from 2 to 4, I'm still increasing, but I switched to becoming concave down. So I take on. Now remember, not only am I switching concavity here at 4, but remember 4 was also a point where the slope was going to be 0. So sometimes when you switch concavity, you don't have to go horizontal with it, but in this case I needed to. So from 4, 0, and then going on to infinity from that point, I'm increasing and I'm concave up. So the graph from here starts turning and going up like this. And that is what that graph will look like, just based on sketching, based off of what we know as far as the domain, the critical numbers, the intervals of increasing, intervals of decreasing, intervals of concavity, and so forth. So, what do y'all think about that? Pretty neat how you can sketch that graph, isn't it?